Hello and welcome to Integrated Math 2. Today we're going to look at symmetry. Now anytime I make a video for you, the expectation is that you write down absolutely everything that you see on the screen. Sometimes, like today, I've made a paper for you that you can just kind of fill in the blanks or work out the examples. But it's very important that you fill that out because that's something I'm going to be checking. And it's not enough to just kind of sit and watch it and put it on mute and just say, okay, well I sort of get it. I actually need you to go through and complete the paper as you're doing the video. So make sure you get your paper out and follow along as we talk. Symmetry is something that just about everybody knows about, but symmetry is something where the figure appears to map back on itself. So something is changed, something is done to it, but we end up with the same shape that we started with. Okay, and there's three different kinds of symmetry we're going to look at today. The first kind is reflection symmetry, and that's when you can draw a reflection line someplace, either up and down or sideways or diagonal, anywhere really, a reflection line where if you flip that figure, that shape, around that line, it flips it back upon itself. So if you think about, let's say, a piece of paper, okay? This piece of paper has a symmetry. I could draw a symmetry line right here because if I flip this paper around that line, I end up with the same shape that I started with. I could also draw a line here because I could flip that around that line and have the same shape. But if I try to go diagonal here, corner to corner, if I flip this one around that line, I don't get the same shape I started with. It's now turned and it's different. So that's not a line of symmetry. It does have reflection symmetry with two possible different lines though. So what I want you to look at is, does this have reflection symmetry? If I flip this shape around this line of symmetry, would I end up having the same thing I started with? Yes, this one has reflection symmetry. How about this one? If I flip this around a line of symmetry, if I draw a line like this, no. How about like this? Not the same. This one does not have reflection symmetry, but this one does have reflection symmetry. You can make a note of that in your notes. The second kind of symmetry is rotation symmetry. And that's when it is possible to turn the figure so that it maps upon itself. So same thing, let's go back to my paper. Here's my paper. If I turn it, turn it, turn it, turn it, turn it, do I end up with the same thing I started with? Yes, so this has rotation symmetry. What about something like this? Does this have rotation symmetry? If I turn this, is that the same thing? Can I turn it? Would it look like this? Is there any way I could turn it and make that happen? No. This one does not have rotation symmetry. Okay? How about this one? Does this one have rotation symmetry? If I turn this, would that be the same thing? Yes. In fact, I could turn this a bunch of different times. In fact, anything that is called regular is the kind of shape where all of these are all equal sides and all equal angles. When it's regular, it'll have rotational symmetry. So this is a regular pentagon, and it does have rotation symmetry. The third kind is translation symmetry. And that's when you can slide the figure so it maps onto itself. Now that doesn't happen very often. No polygons have translation symmetry because I can't take this shape, slide it, and it's not really the same thing because it's not really in the same position. To have translation symmetry, you have to have something that's kind of going on forever. So if you have this line maybe that's going on forever, you kind of have to imagine it's still going. If I slide it this way, is it still the same thing? Still going on forever, and I've got the same thing here. So this lines do have translation symmetry. If they're infinite and they keep going, they have translation symmetry. So yes, this has translation symmetry. By the way, does this have reflection symmetry? Could I flip it? Yes, it does. Does it have rotation symmetry? Could I make a point and turn it? Yes, it does. This has all three kinds of symmetry. Now, how about these? We'll try these. What kinds of symmetries does this one have? Could I make a line here, let's say like this, and flip it? If I flip this on both sides, would I end up with the same thing I started with? Yes, indeed. This has reflection symmetry. How about rotation symmetry? If I turn it like this, and I bring this quadrant 3 up to quadrant 1, would that be the same shape? Yes, it is. So this has rotation symmetry. How about translation symmetry? If I just slide it, and I make this thing go up here and this one go up here, would it be the same thing? No. So these are the two kinds of symmetry that this one has. Okay? Think about this one before you see my answer. So pause the video, think about it yourself, and then restart the video and see if you got the same thing as me. Okay? Does it have reflection symmetry? If I flip it this way, would I get the same thing? If I flip it diagonally, would I get the same thing? I don't think so. How about if I flip it this way? No, not reflection. How about rotation? If I spin this thing, maybe if I spin it from like this point, if I spin this whole thing around, would I have the same shape? Let's see, this one would come down here, it would go up, but it would be a little different. It would end up going up instead of going down, so that wouldn't be the same thing. How about translation? What if I slide, it looks like these arrows say that it keeps going in these directions. How about if I slide it? Would it keep doing this pattern? Yes. So that's the only kind that this has, translation symmetry. Okay, how about this star? That line of symmetry here, could I flip it and get the same thing? Yes, I could. I could also do it like this. So this has reflection symmetry. How about rotation? If I twist it and turn it, would it end up being the same thing? Yes. How about translation? No, it's a polygon. It's not infinite. If I move it, it's now different. So these are the only two types of symmetry this has. Finally, how about the letter H? What do you think? Could I flip it? I could flip it this way. I'd still have the letter H. I could even flip it this way, and I'd have the letter H. So it has reflection symmetry. How about rotation? Can I turn it all the way upside down? Yes. How about translation? If I slide it and I put my H over here, is that the same thing? Nope. It's not in the same position. It's not infinite. There are only going to be translation symmetry whenever it's infinitely going. So again, these are the two types. Hope that helps. Be prepared to answer questions about symmetry.